Example 3.1. Determine all the node voltages and the powers of the three current sources, which are active or passive. So the thing that you want to think about here is that this circuit mixes up ohms and milliamps. This is a nightmare to deal with. If not dealt with properly. So we want two simplifications. Okay, the first one is that circuits with kiloohms always produce milliamp currents. So that means here you want to convert ohms to kiloohms. So if you look at that, we have three resistors. We have a 100 ohm. Now convert that to 0.1 kilo ohm. And we have a 200 ohm, 0.2 kilo ohms. So when you do this, all voltage calculations will automatically be in units of volts. As an example here, we see here that V is then going to be R times I. And so if I put it into kilo ohms, you could see here is that I'm going to get kilo ohms times milliamps. But note that these guys are going to cancel out, right? That's 1,000 divided by 1,000. And so that gives us units ohm amps, which is what we call a unit of a volt. So that's a really important factor here. So the second thing you want to pay attention to is that you want to convert the circuit to proper units. So here we go. So the first thing that I'm going to do is that I got to convert the circuit. So if I look at this guy, I'm going to have what? So I'm going to have a circuit that looks like this. I have a current source. I have a 4 milliamp. Then we're going to have one resistor that goes here. And I have another resistor here. And so I'm just going to keep drawing these guys in. And I know that this is a 1 milliamp. Then I have one resistor here. And then I have another current source right here. And so this is a 4 milliamp. And then we know that this is 0.1 kilo ohm. This is 0.2 kilo ohms. And then we have a resistor up here. Which is then going to be 0.1 kilo ohm. Oh, this is 0.2 kilo ohms. So what I'm going to do here is that we don't want to keep units of milli and kilo. So what we want to do here is that I'm going to come over here and I'm going to paste this right here. And this is what you want to do. As I go over here, what you want to do here is that you want to drop all kilo and milli units. So that means when I look at my source here, it's really 4 amps. And then I take all of my Ks out. And then again, I'm going to have 1 amp and then 4 amps here. And I'm saying that this is a circuit that you want to deal with right here. Okay, this is the circuit. This is the circuit you solve. Not the one with the kilo ohms. Okay, not the one with the kilo ohms. You solve this circuit. So let's copy this and let's get going here. So now what I'm going to do here is I'm going to do the same thing that we talked about in lecture, is that now I'm going to start my process. So I'm going to do step 1. And step 1 says, do the counting. So when we're looking at this counting, what we want to do is we want all node voltages and all powers of these sources. So let's paste this in and let's get going. I'm going to do all the counting. So here's the circuit. I'm going to paste this guy in right here. Then I'm going to do some editing. And so now I start labeling. So the first thing I got to do is you got to pick a ground. Probably the most common place to pick a ground right here would be down here at the bottom. So here's my ground. And we know that's 0 volts. So then I'm going to use colors to actually do this here. So here I go. So here's going to be, let's say this is my first node. I'm going to call this node V1. I'm going to call my green node V2. And then I'm going to call this middle node V3. Okay. So now what I want to do here is that I want to do the counting. Okay, so this is the number of nodes. And when I look at the number of nodes, you could see that I have red, green, blue, black. So that means I have 4 nodes, but we know one of them because that black node is 0. So what this really tells us is that we have 3 unknown node voltages. And so what are those voltages? 1, 2, 3. So what we want to do here is that we want to use node analysis, use node to generate 3 equations for my 3 unknowns, which will be V1, V2, and V3. So the result of the counting tells me that this is what I need to do now. So now I'm going to go and I'm going to apply node analysis to each node. So here we go. So now we're at step 2. And it says apply node to each node voltage. Okay, so let's focus on this red one now. Okay. So I'm going to look at node 1, which typically I label this as node 1. So here we go. So I'm going to focus on the red node, and I ask how many resistors are connected to the node. We see that there's 2. So there's 2 connected resistors to the red node, and that gives me my node V1 voltage right there. And then I have to subtract the mutual. So you can see that there's a connected to the red and a blue connected to the red. So then I'm going to come in and I'm going to say, okay, so then this will be 0.1, and that's going to be V2. And then I'm going to get 0.1, and that's going to be V3. So if I come in here, I'm going to write V2, I'm going to write V3, and I'm going to subtract that. Now I look at the currents sources. Look at the red node. The 4 amp source is flowing into the red node. So that becomes a positive 4. So this is my first equation right there. So again, what am I seeing here? That positive tells me is that it flows into node 1. Now let's go to the second node. So the second node is that green node. Okay, so I think I might have to bring that circuit down. Okay, so if I look at that second node, note that I have 1, 2 resistors connected to the green. Then I have mutuals with the blue and the red. Here we go. So let's write that out. So now we have node 2, which I write as N of 2. Then I focus on the green. So the greens has a 0.1 and a 0.2. So I'm going to sum those. So it's going to be 0.1, 0.2. And that's connected to the green node. Now I'm going to subtract the one from the red. So if I subtract the one from the red, it's 0.1. And that's connected to node 1. And then I'm going to subtract the green node, the blue node from there. So I'm going to get minus 0.2. And that's going to be the blue node, which is V3. And then I look at the current sources. So if I look at that green node, note that there's only one current source. It's that 4 amp, and it's flowing away. So what you're seeing here is that from this green node, you get a minus sign because it's flowing out, and that's going to be my 4 amps. So this is the equation 2 here. And so when I look at this thing, this tells me right here that this flows out of node 2. Then I'm going to repeat for the blue node now. So now I'm going to call this node 3. And you can see here that I have 1, 2, 3 resistors. So let's sum them up. So it's going to be 0.1, 0.2, 0.2. And that's going to be my blue node. That's how many are connected to that. Now, what are the mutual ones? Look at the 0.1s connected to the red. And there's the red right there. And then the green, you could see is connected to the 0.2. And here's my green. And note that there's one connected to the ground, the 0.2. So then I'm going to write 0.2. But this guy's connected to the ground. And because it's connected to the ground, you could see right away that this guy's going to do what? It's going to cancel out to 0. So it doesn't contribute at all. So now let's look at the current sources. So if I look at the current sources, there's the blue. There's only one connected to the blue, which is this 1 amp, and it's moving out. So then I have to write in what? A minus sign because it's coming out. And so this guy's going to be 1. And this is equation 3 here. So you could see that I have minus signs. Oops, wrong. Always 0. So if you see a resistor connected to the ground, the mutual part, you don't actually have to worry about that. So now what I'm going to do here is that I'm going to rewrite these equations. And the way I'm going to rewrite them here is that I need to put them into matrix form. So I'm going to place these equations into matrix form. Or, I'm going to get tight here. So I'm going to move this down 1. For easy grading for me and organization or calculations for you. So the way I'm going to set this is that I know I have 3 equations. And what I'm going to do here is I'm going to set up a column of V1. Then I'm going to set up a column for V2. Then I'm going to set up a column for V3. And then I'm going to set up a column for constants, which are on the right side here. So now let's focus on equation 1. So if I look at equation 1, you could see that I got 0.00 like that. So I'm going to go write this down now. So what this really tells me is that I'm going to get 0.1, 0.1. And this term is V1. And then if I look at 2 here, it's going to be minus 0.1 times V2. And then I'm going to get another 0.1 times V3. And then what you're going to see here is on this right side, you see that I have a +4 constant. So I'm going to write +4 right here. So now if I start to look at this thing a little bit better here, I'm going to go look at equation 2 now. So I think I'm going to make this just a tiny bit smaller so that we can see it. So 2 here. Now look what I'm going to do. I'm going to take my second equation and I'm going to collect my V1s now. So if I look at, I'm only looking for the red here. So then this will be minus 0.1. And this will be V1. And if I look at my equation 3, you might get the hint of where I'm going. Look at this red one right here. This is also minus 0.1 for V1. So you're seeing I'm organizing them like this here. Now let's look at V2. Look at V2 for equation 2. I'm going to get 0.1, 0.2. And note that that's a plus sign right there. And then this gives me V2. Now look at the third equation. The third equation gives me a value that's what? It's going to be minus 0.2. And there's my V2s right there. Now let's look at the V3s. So if I look at the V3s, you can see that that's my V3 right there. So I'm going to get minus 0.2. And this will be V3. And if I look at the next one here, look at that. I have all those terms there. So I'm going to get 0.1, 0.2, 0.2. And you could see that has a plus sign, and this is V3 right here. So it looks like I'm going to have to move my constants a little bit over here. So if I look at that, look what I'm going to get. So now I'm going to look at all of my constants on the right-hand side. So I got -4 and I got -1. So this is -4, -1. So now I have everything organized. So now I'm going to put this into matrix form. So here we go. So I'm now going to say, let's go put this into matrix form. Right? So now this is going to be placed into matrix form. So here's what I'm going to do. I'm going to collect all my V1s right here. Okay, so this is going to be V1. I'm going to have my V2 right here. I'm going to have my V3 right here. And then I'm going to have my constants. But now look what I'm going to do. I'm going to go right down the row and look what I'm picking them out. I'm picking off only the reds. So if I do the reds, this is going to be 0.1, 0.1. That's my term. Look at my second one. It's going to be minus 0.1. And then my third one's going to be 0.1 as well. So this is going to be a matrix. So if you look at the blues here, or excuse me, oh, I did it wrong here. This is green, not blue. So I'm going to write the 2's here. So now if you look at the 2's, look at that. I have the first term is what? This is minus 1 over 0.1. If I look at the 2's, this is going to be 0.1, 0.2. And then finally, I'm going to get minus 0.2. And then if I look at the bottom here, this is going to be 0.1, 0.2, 0.2. You could see that I'm doing the bottom here. And then if I come up, this is going to be 0.2. And then finally, this is going to be 0.1. And these guys are going to represent my V3s. So this is my matrix now. So if I look at this guy, here's my matrix. And if I multiply this by a column vector, then this guy represents V1, V2, and this represents V3. And on this side, I'm going to have my constants. And we saw that the constants all equal what? 4, -4, -1. So this is my matrix right here. You must show me this matrix to get full credit on a problem. And then what I'm going to do here, following the matrix techniques that we talked about in lecture, I now do a little bit of matrix magic. Right, so now we have matrix magic, and it looks something like this. We have a solution. So we have V1 is then going to be minus 0.1 volts. This is going to be V2, which will be minus 0.2 volts. And then this is V3, which will be minus 0.4 volts. And so these are the node voltage solutions here. So the key thing here is that these are not voltages, but node voltages, which is the same as equipotentials. Okay, so here we go. What does this tell us? What do these values tell us? So what I'm going to do here, I'm hoping I still have yeah, good. I still have it right here. So let's go look at what we've done. So here's our circuit, and we know that this is the ground. So now what I'm going to do here is that I'm going to go and I'm going to put in the numerical values for these guys. So we know this is the red, and we call this one V1. So V1 is then equal to minus 0.1 volt. And then I have V2, and we said that V2 is minus 0.2. Then we have our blue node. So this tells us here that this is V3, which is equal to minus 0.4 volts. So when we look at voltages here, node voltages, so note minus 0.1 volt versus 0 volts. This guy right here is the low. This guy right here is the high. So what this does here is it tells us about the height that a charge falls. So the height, the electrical height, is the difference in voltage. And in this case, we go from the high to the low. And that value is always positive. So if I look at this thing in picture-wise, it looks like this. So I'm looking like this. So what I'm seeing here, let me move this over a little bit. So the way we interpret this is a low. So what we're seeing here is that down here, this represents a negative term, right? So this guy's going to be the negative term, and it's the lowest part. And right here, this low part is 0.1 volt, and that's because that's the low. And if I come up to here, that's the high part. And in this situation, this high part is 0 volts, which is the high. So what we want to do here is that in order to calculate the power, this tells me then I need the voltage of where the source is at, and the height change here is then going to be what? If I move this over a little bit, the difference between the heights here is that tells me that this height is going to be 0.1 volts. That's the height difference between the high and the low. And if I calculate this mathematically, this goes 0 minus 0.1. And of course, that's 0.1 volts. So now let's go calculate the power. So to calculate the power of a current source, we use that the power is then going to be the voltage times the current, which is then V high minus V low times the current. So the key thing here is that it's the direction of I that determines passive versus active. So let's go look at that. So what I'm going to do here, I think we're going to have to probably bring this circuit down. I think it's going to be the easiest to do this, just so that we don't keep, well, let's see. How am I going to do this? Okay, so let's look at, I'm going to look at the first current source, which is the 1 milliamp. Okay, so if I look at the 1 milliamp, I'm going to say, no, let's look at the one on the left. So so the first thing I'm going to look at, so I'm going to look at this guy here, and I want the power of the 4 milliamp source, which should be the voltage of the 4 milliamp times the current of the 4 milliamp. And this one's going to be the left one. So we're talking about this guy right here. So let's draw this guy out. So if I look at my current source there, here's what I see. I see a current source that looks like this. And I know that this guy's a 4 milliamp. And when I look at this, this guy has this node right here. And we know that this node right here is V1, which is minus 0.1 volts. And then what you're seeing here is that down here, I have my ground, which is, of course, at 0 volts. So when I look at this thing, I could see here is that the voltage height of this 4 milliamp, from what we've already said here, and I'll just redraw this to be clear, looks like this. So we see that this guy here is my red node. Oh, nope, that's wrong. My red node is the low, so this guy right here is my, wait, yeah, this is minus, let me write this right. So this is going to be minus 0.1 volts. And then up here is my ground. So look at the direction of the current. This current is doing what here? You're seeing that the current is going from the high to the low. So if I look at my source here, this is 0 volts. So you could see that the current is doing what? It's coming down in this direction. And that's my 4 milliamps going like that. So what you're seeing here, going from the high to the low. So that means if I go from a high to the low, that means it's entering the positive terminal here towards the negative terminal. So that implies here that this is a passive current source. And because it's passive, we then say the following thing here. We know that the power of the 4 milliamp is then going to be the voltage of the 4 milliamp times the current of the 4 milliamp. But because it's passive, we automatically put a positive sign. So that sign tells us that it's passive. So if I look at this thing, this is then going to be the voltage, which is 0.1 volts, and then the current is 4 milliamps. So now you see that this guy becomes positive 0.4 milliwatts. And that's the power of the 4 milliamp source. And as we already said, because it goes from the high to the low, this is passive. Let's go to the next one now. So the next one I'm going to do is that I'm going to do the 1 milliamp, which of course has to be the voltage of the 1 milliamp times the current of the 1 milliamp. And so if I look at this guy, what am I seeing here? Well, if I look at that, I have a blue node at the top of the current source, and then the bottom is the ground. So let's look at this guy. So it looks like this. So if I look at this thing, excuse me, the picture looks like this. So I have a blue node here, and then I have my current source, and it goes like this. So we know that I have a blue node right here, and we said that that blue node tells me that its V2 is minus 0.4 volts. And then the ground, we know that in this case, that represents the high. So this guy tells me that this is the low. This one tells me it's the high. So when I look at this thing, I'm going to reinterpret this as an incline. So if I look at this thing as an incline, the blue is the low here, which of course is at minus 0.4 volts. The high is the ground, which is of course 0 volts. So this is the high, this is the low, but look at the direction of the current. The current goes from low to high. So that means my source here says that it's taking a current uphill. So when I look at this height here, so then I know that this height right here, from here to here, that has to be the voltage of the 1 milliamp source. So here we go. So the voltage of the 1 milliamp source is then V high minus V low, which then gives me 0 minus 0.4, which then gives me a positive 0.4 volts. So this tells me, because of this reason right here, this guy is an active current source. So let's calculate it. So then I have the power of the 1 milliamp. So I need the voltage of the 1 milliamp times the current of the 1 milliamp. And then I'm seeing I have to put in a negative sign. Why? Because it's active. So then if I look at this guy, it's going to be 0.4 volts times 1 milliamp. That gives me 0.4 milliwatts, but oops, let me be careful. I need to put a minus sign. So this is a minus, so it's 0.4 milliwatts, and that's the power of the 1 milliamp. And we know this is active. So now the last one here, I'm going to do the power of the 4 milliamp, which again will give me this guy again. But this one is the right one. So it's on the right side of the circuit. So let's go look at this thing. So if you look at the circuit up here, you could see here that it's going to be this guy. So it's the green and the black. So if you look at this thing, this is very, very similar to the one in part 2, right? Because that has a minus, oh, this is a -2, not a -4. So the same process occurs here. So let's draw this out real quick and then move through this. So here's what I have. I have a current source that looks like this. and we see that it's going to be going towards the ground. We already know that the ground is now the high here. So this represents the high part of the circuit here. This guy is the low, and we know that this guy, V2, is equal to minus 0.2 volts. So if I keep following the same process here, moving a little bit faster, we could then say that the height change for the 4 milliamp, right? So this guy's going to be the 4 milliamp, has to be V high minus V low. And in this case, that's got to be 0 minus minus. So I'm going to get 0.2 volts. So then this guy is the height of the incline. And now I got to pay attention to how the current flows here. So we know that the green is the low, the black is the high. And then let's look at the current now. Look at the current. It goes from the low to the high. So if I look at my source here, it's saying, yep, I'm going uphill. And that definition means that it's active. So if I take the same type of analysis that we did before here, so now I just got to multiply the voltage and the height here, and the current. So then I'm going to say that the power of the 4 milliamp, of course, is the voltage of the 4 milliamp times the current of the 4 milliamp. We agree that this guy is active. So because it's active, then I'm going to multiply the voltage, which will be 0.2 volts times 4 milliamps. So then this gives me minus 0.8 milliwatts for the right guy, the right current source on the right side of the circuit. And we see that this guy is active.